Hello, everyone. I want to begin by acknowledging that this public talk takes place on unceded Coast Salish territory. These are traditional territories of the Squamish, the Musqueam, and the Tsleil-Waututh peoples. Thanks for coming, everyone. I'm really pleased to welcome Dr. Alessandro Delfanti to Simon Fraser University. Dr. Delfanti is a postdoctoral fellow at McGill, McGill in Montreal, where he researches the role of participatory media and biomedicine, and teaches a seminar in online cooperation. He teaches the sociology of new media at the University of Milan. He's a journalist who writes about science and digital culture in a number of Italian publications, and his first book is called Biohackers, The Politics of Open Science, and he's here to discuss that with us tonight. I also want to mention that in addition to his scholarly research, Dr. Delfanti has been at the forefront of autonomous labor organizing politics in Milan. He's a member of the San Precario Network, which is a labor network organizing among precariously employed, migrant, and otherwise unrepresented workers in Milan and beyond. And we're very pleased and lucky to have him visiting and to have the opportunity to hear about his work here in Vancouver. And so before I begin, I'd like to acknowledge that this event has been generously funded by the Institute for the Humanities at SFU and SFU's Vancity Office of Community Engagement. So please join me in welcoming Dr. Alessandro Delfanti.
Thank you, Enda. And well, I'm a precarious worker myself, of course, which makes it easier to work as an activist in that world. Well, first of all, thank you for inviting me and for bringing me to Vancouver after a few years. The last time I was here, it was in 2010. So it's a pleasure to be here, and I will be able to spend a few days in the city. I want to start out by saying that I am a free culture advocate myself and activist, so I have a bias when it comes to openness, of course. But on the other side, in my work, I try to highlight, let's call critical points about openness, or if you want, the dark side of openness in science, in particular in science, and. This is what I did in the book, which is sort of an exploration of the cultural and political significance of openness in contemporary biology, and how openness relates to issues of power distribution, evolution of our information societies, and so on. And in particular, I look at the influence of that hacker cultures have had and still have on the evolution of biomedicine. Bringing all their heterogeneity and craziness and diversity to the now digital world of the life sciences. So the aim of the book was to complicate this rather static opposition between open and closed, which always structure the public debate when it comes to science, and to challenge this recurrent sort of monodimensional rhetoric of democratization related to openness. Open science is sort of an umbrella term, of course, because it can include very different practices and very different social groups and very different phenomena. For example, we're talking about, under this umbrella term, I would include alternative licenses for distributing scientific information and knowledge, open source, so open source of scientific data, open access to scientific or scholarly publications, new forms of cooperation enacted through the internet, and new forms of inclusion of different strata of citizens in the scientific enterprise. Of course, the stakes of open science are high, and information and knowledge circulation are crucial battlefield, according to me, for science and technology, but also for the evolution of our societies in a broader sense. And according to some historians, the battles around intellectual property rights that happened over the last 2-3 centuries, at least, were foundational in the evolution of our societies. So I think that this war that was at a certain point maybe stable is sort of unstable again, and digital networks magnify the importance of the way in which information is managed, distributed, and commercialized, and so on. For example, information, of course, is a commodity in a global market. And so in the book, I try to highlight the conflictual side of openness and the conflicts that have emerged and have made science unstable again, in a sense. And the outcomes of these conflicts, of course, are not predictable yet. So what I try to do is to give like sort of a broad picture on different kinds of openness and their role in contemporary sciences. But of course, these conflicts highlight traditional oppositions, such as the one between public and private, or centralized and decentralized, and thus allow a glimpse at, I want to say, profound transformations of our societies. So for today, I decided to present a new case study, which is pretty much related to the core subject of the book, but apart from the fact that it's not on biology, and it's the birth of the Journal of High Energy Physics. So we're going to switch to particle physics tonight, if you allow me. And well, very quickly, it's one of the first. They were called electronic and not online journals that emerged in the mid-90s and quickly became established as one of the most important journals in its field. It was started at Sissa, which is my former university in Trieste, in the far northeast of Italy, by a handful of particle physicists. And we'll talk about what JHAP. The nickname is JHAP. We'll talk about it in a minute. I want to acknowledge the fact that, of course, by focusing on JHAP, we'll miss out some themes that are present in the book, and that might be interesting for you and for me, of course. But we can talk about those issues and problems in the Q&As if you want, and such as of course the link between life sciences and capitalism, which is pretty peculiar. The role of countercultures in the evolution of open science. It's not the case for JHAP. It's old, mostly Jewish, former communist, particle physicists. So, of course, they don't belong to any counterculture in the Western sense of the word. And we also miss out some of the spectacular and performative side of open science, so the relationship to mass media, in part. But of course, on the other hand, I think it's a good case study that provides sort of a genealogical view on technological evolution and on the evolution of the meaning of openness in science. And it's pretty much related to institutional change and power change. So from that viewpoint, it's a very interesting case, according to me, that goes to the core of the meaning of openness in science. Sorry about my funny Italian accent, but you'll have to keep up with it. Okay, so I wanted to start with this sentence taken from the Budapest Open Access Initiative, which was written in 2001, and it's still one of the most important documents of the open access movement. So I want to highlight that it starts out by stating that the convergence between an old tradition, which is the sort of naturalized or socialized, culture of sharing that scientists are supposed to have, and the new technology, which of course is the internet and digital network, the networks make possible this unprecedented public good, which is open access science. So my point is exactly that this old tradition and the accent of a new technology are not enough to explain the complexity of open science. So that the old tradition has been remixed with new or more contemporary cultural traditions, and that new technologies can have a very ancient genealogy and strong resistance to change. So this case study will allow me to talk about open access scholarly publishing in particular, and to highlight those two poles, let's say. Also, this is sort of an ideological viewpoint, if you want, because it tells this story about this pristine, corrupted Eden that can be redempted, right? And I think this is too static and too simple, at the very least. So what I'm going to focus on tonight are disputes that need to be solved and changes that need to be made. And in those stories, open science is not just an old tradition and which uses a new technology, but I think it's sort of a source of new cultural tools and new strategies of action that can be used and mobilized and used in what the French sociology of critique would call critical moments of change, moments of transformations in which people need to update their cultural toolkit. So I don't see open science as a program of liberation, but as an ambivalent phenomenon in which can support very different phenomena, such as new business models that go against corporate incumbents, for example. Institutional change and critique to against bureaucracy, which is the focus of the case studies I'm going to present tonight, and also more inclusive and participatory science, which can enact processes of power redistribution. So it's a very ambivalent and differentiated phenomenon according to me. But after all, this is still a book presentation, so I'm going to quickly go through the case studies that are in the book. Just so that you can see what I mean by this complexity and ambivalence of open science, and then if you're interested in any of them, we can discuss them later. So I'm sorry if I go very quickly through them, but just to give you a sense of what's in the book. After all, it's supposed to be a book. It's supposed to be a book presentation. Can I ask you for some water? I'm running out of. Thanks. So in the book, I collected 3 case studies of very different research projects related to biomedical research. So the first one is Craig Venter. I don't know if you have heard of his. Well, you all know Craig Venter, maybe? No? Okay, he's a. Oh, thanks. Very famous biologist who in the 90s became sort of the bad boy or the Darth Vader or the Darth Venter of biology, because he was working for the Human Genome Project at the time, and for the NIH at the time, excuse me, and he started his own private company that basically engaged in a race against the public Human Genome Project in order to sequence the human genome. And he won the race, and a part of this race was based not only on being faster than the Human Genome Project, but also on patenting genetic sequences. So he became sort of the evil guy of science privatization. So with this project, the Sorcerer II, which is this research vessel operated by the Craig Venter Institute, he engaged in a scientific expedition called the Global Ocean Sampling Expedition. And from 2003 to 2006, he basically went around the world remaking Darwin's famous voyage in the 19th century, and extracting bacteria from the seawater and sequencing them and building a huge metagenomic database, which means that you put together genomic data and environmental data to see which genes operate in which environments. So for the first time, Venter decided to go for an open access and open source model. So he basically published all the data in an open access database, and the paper is coming from the research project in PLOS, so the biggest open access journal in the field. So it was, according to his public rhetoric, he was cracking and sharing the ocean code. So in this case, Venter basically claimed independence from both the academic and the corporate worlds in order to find new alliances with private corporations, such as Google, for example, foundations, public funding institutions, and mass media. And as he said, he managed to be hated by both worlds, so by the academia and the corporate world. So in this case, it's sort of a neoliberal digital capitalism that incorporates open science practices in order to basically remove, if you want, obstacles to free competition. The second case was Ilaria Capua. She's an Italian vet and a virologist. And in 2005, when the big H5N1 outburst erupted, in her lab she sequenced one of the first genomes of the virus, and she was supposed to deposit it in the WHO database, which was at the time closed and accessible only to a handful of official labs working for the WHO. So what she did is that she engaged in this public dispute in scientific journals at the beginning, Nature and Science, and then in the mass media, from the New York Times to the Wall Street Journal and so on, in order basically to push the WHO to change their policy, denouncing an old boy network. The data were kept under wraps in password-protected archives, and she started her own database, GISAID, so the Global Initiative for Sharing Avian Influenza Data, if I'm not wrong. Open access, of course. In the end, she managed to push the WHO to change, and now the WHO publishes everything on an open access model. So in that case, she was depicted by the media as a rebel and a revolutionary against this old, creepy bureaucracy that was keeping information under wraps again, and managed to subtract data from the influence of this evil bureaucracy according to the media narrative. So in this case, we're talking about a liberal ideal of transparency, which still is also involved in institutional change and power games. So she basically managed to be the one who for a while managed the bulk of data sharing related to influential data. And the third case study is do-it-yourself biology. I don't know if you're familiar with this movement or network. Nope. So it's a citizen science movement that was started in the US in 2008. And basically what they do is open hacker spaces for the life sciences, so community labs where people can go and share skills, information, and the physical space, of course, and equipment and so on. And in this case, the openness that's at stake, it also means opening up the boundaries of scientific institutions in order to make them more inclusive. And this is a very fascinating case study, and lots of people are working on it actually right now all over the world, and it spread out to Europe and to Southern Asia, so it's now sort of a global network. What's interesting is that for do-it-yourself bio, openness means also dismantling monopolies and bureaucracies, as in Venter's and Capua's case, And it's both in the sense of making them more inclusive. Like one of the sentences that they told me when I was doing participant observation with them: "We're all doctors in here, man. So science should be less formalized and more open to different kind of expertise." On the other side, they also want to disrupt commercial monopolies. So mostly in the US, West Coast, but not only there, they're trying to set up biohacker spaces that are intended as startup incubators. So their dream is to basically fight against big pharma, or big bio as they call it, in order to enact this new environment of smart and openness-based startups that could renew how biologists performed. So again, the ambivalence of openness is present in this case study as well. But yeah, now we'll shift to particle physics. And again, if you are more interested in the biology case studies, just feel free to ask me anything at the end. So particle physics is a fascinating field from many viewpoints. This is what's happening right now. So since January 1st, 2014, the whole particle physics system has switched to an open access model. So this consortium has been negotiating with publishers for a few years, and now all the major particle physics journals, even the ones that are published by commercial publishers, switch to an open access model, and the consortium is going to pay for the open access model. So they basically switched the way scholarly publishing is funded. So it's not your traditional model. Libraries pay fees to publishers, which then allow them to access the journals. It's not the traditional open access model like the green model, which means that the author pays in order to make the article open and accessible. But it's this bureaucracy that negotiated with the publishers a price for each journal, and let's say that JHAP gets $1,500 for each paper that it publishes, and then it has to be open, and the consortium pays for it. Physical Review Letters B gets $2,000 for each paper that they publish. So it's a weird way to sponsor open access, but what's interesting is that it has switched completely the whole field. So the 12 journals that are now part of the consortium basically represent more than 80% of the publications. So it's going to be one of the most radical and most important open access initiatives that we have right now. So a very radical change. I mentioned this because JHAP is part of the genealogy of this consortium, and also because when people describe SCOAP 3 as a revolutionary radical initiative, it's very interesting to see how its genealogies are not that radical and that revolutionary, if you want. So let's go back to JHAP. It was launched in 1996 by, again, this just handful. Like we're talking about 6 guys at CISA in Trieste. So it's a small group of physicists that started it. It wasn't gold open access model. It wasn't green open access model. I don't know if you are familiar with the two different funding models. It was just free. So libraries wouldn't pay, authors wouldn't pay. It was completely free. So financed by CISA itself and by the Italian National Institute for Physics. Again, it's interesting that it's a particle physics case study because the field itself is very peculiar from many viewpoints. So since the 70s, with SPICE and other databases, the particle physics started organizing repositories of paper that were freely accessible on networks. One of those repositories was based at CISA since the late 80s, it was called Babbage, and it was merged with other repositories and became the archive. Do you know what the archive is? Ever heard of it? No. Okay, so it's a repository of papers, of preprints. So you all know what a preprint is. So it's a paper that's not been submitted for peer review to a journal yet. It was started in 1991, if I'm not wrong, and it's now operated by Cornell. And this is the medium that physicists and mathematics, and as you can see, well, there's a longer list, but all the disciplines related to physics, and basically physics, mathematics, and now also computer science and computational biology. You can imagine that kind of area. So this is the medium that they use. So it's a preprint archive. This is what they open in the morning when they go to the office. Often they sleep there. So when they wake up, they're already in the office, as if you know some physicists. So basically, this is where papers in physics and mathematics circulate. So you finish your study, you publish it on the archive. It's free. You just go there and publish it yourself. There's no peer review, and this is where all your colleagues will download it and read it. It basically mirrors the system of preprints that they had in place before the internet, which were, well, boards where they will post letters, like physical letters made of papers that they would exchange before submitting the paper for regular publication. Of course, there are other peculiarities to the particle physics field, like the fact that it sort of co-evolved with the internet and with the web. So of course, I guess you know that the World Wide Web standards were written at CERN in Geneva. Is it Geneva in English? Oh, okay. Well, it's in 4 languages, so of course it's also Italian, French, and German, I guess. So it was the standards were created at CERN and were freely shared, and they make the internet as it is now, right? There is also a cultural drive towards transparency in parts of the particle physics and the high energy physics field, and which dates back to the Manhattan Project. So after the Manhattan Project, I don't know if you know the story of Einstein going to the president, asking him to make the bomb transparent, the processes to build the bomb transparent in order to enact sort of a safety to truth and transparency. So there are also cultural, if you want, characteristics that make this field sort of peculiar. And it's also sort of a small field, so it's a handful of journals. So it was maybe easier to intervene in this field, also from that viewpoint. So to go back to my research, it's a research project that's still going on. So it's sort of a preliminary presentation that I'm giving tonight. And I've been interviewing all these physicists that still work at SIS and live in Trieste, and I've been doing desktop research, and I've been also working with the people who run the journal from the administrative and technological side, with interviews again. And I want to highlight in this presentation basically 3 main points that, according to me, are very interesting in JAP's story. The first one is that it was launched in a period in which you had a number of declaration of independence from journals. What does that mean? The inspiration was taken from this Declaration of Independence, but this meant that the whole editorial board of a journal will quit the journal publicly with a public statement and start a new journal with a very similar name, Open Access, but basically the same journal. So they will kill the old journal because they will leave it altogether, the whole editorial board, and the commercial publisher that was operating it was just, they had to basically conform with it. So you had evolutionary ecology that became evolutionary ecology research, for example. So those kind of shits. So in that period you had Declaration of Independence, which were like a strong political statements for open access. And that's what JHAP did, even though they didn't split from a previous journal. So the the sentence that you saw in the website already it's still there. A journal by scientists for scientists. So this happened in a public discussion, which happened, of course, in their internal journals. So the commercially operated journals, Physical Review, Letters B. Well, I can't remember all the names, but there are three, four journals in which the discussion was made within the community, and it was a political choice. It was framed explicitly as a political decision. One of the main reasons was to protest against Elsevier, which was already perceived as an evil player in the publishing industry. Basically because of the prices, the fees that they charged, and the way they sort of exploited this free labor of reviewers and the editorial board. You know it, right? So the first thing that they did was to involve the community in sort of this political debate in order to build momentum and attract people that later became reviewers and authors, of course. So in order to start a new journal, if you want to make it seriously, you need to attract big names. You need to convince big names to send you papers, right? Because otherwise you will publish your like low level, let's say research at the beginning, and you won't be able to grow. So what they did was to involve big names in the community in order to make them contribute with papers and reviews. They went to CERN. They talked to people. Apart from discussing this in public in journals, they also went in the major physical spaces where the community was operating, which CERN, of course, is the biggest one, in order to convince people. So it was clear since the beginning that it has to be like a community-driven and community-operated journal. Which kind of journal did they decide to launch? So this is very interesting, according to me, because it says a lot about the resistance to change that can be part of the genealogy of digital media. So according to their geeky jargon, it was a migration. So they migrated a pre-existing system, which basically is the journal model that was started in the 17th century with the philosophical transactions in England, and they just migrated it onto a new technology. Well, they use this jargon because, of course, particle physicists are also programmers, so they did write the code themselves. They were helped by technicians, but that was sort of a secondary role that they had. So basically, they designed and also and even wrote part of the journal. So it's very interesting because they got to the point of even splitting the group that started the journal over the problem of technological evolution. So which kind of journal we're gonna launch? We have it's a new medium, it's a new technology. We have any kind of possibility. So some people in the group advocated for an innovative model. So for example, one guy proposed to make it something that now we recognize very easily, like the Amazon model, sort of an overlay to the archive. So the archive is already there. So papers are there. So why don't we build a software that goes and certifies the good papers that JHAP likes, that JHAP reviews and then likes? But there was a huge resistance, again, to the point of basically kicking this guy out of the group, which according to me is very interesting because it shows the robustness of media formats. And people have talked about zombie media to define undead media that are supposed to die anytime soon and never die. So maybe the scientific journal is one of those zombie media. Because again, the model is that of the first journal, the philosophical transaction. So the resistance to change. So a strong resistance to change. And the last thing is that openness was not really the point. Why? Because they don't read journals, they have the archive. So making the journal open access was not because of an ideological decision. It was not even practical because physicists don't open journals' websites literally. So they go to the archive. Of course, they open them because they need you need a journal article for your CV. Okay, but it's not the way you circulate your knowledge and information you produce. So the role of openness was completely different. It was sort of a justificatory apparatus that they adopted as a tool in order to engage in this political fight against the other publishers. So openness was sort of a flagship characteristic of the journal, but was not the main point. And actually, after a few years, that completely free open access model was proved not to be not sustainable. Public institutions started questioning them over the funding that they were receiving. It was a small collective that was running the journal, and the thing was not sustainable anymore. As the journal grew, expenses grew in terms of bandwidth, technical support, and you can imagine editorial support. You can imagine. So they basically sold it to the Institute of Physics, and which closed it again after 3-4 years of open access model of this open access model or the free access model. They didn't sell the journal because the journal is still owned by CISA, but they outsourced it first to the Institute of Physics, and now it is operated by Springer. So it's the only difference now between JHAP and other journals is that it is online only. It doesn't have any printed version. At that point, it was already one of the most important journals in its field, and now, if we had to take this as a measure of its success, its impact factor is like the first among its in the field. So openness not as a political or ideological goal, but openness as explicit as a tool in order to solve a problem and solve a dispute and convince the community to join them. So from this viewpoint, it's maybe the history of a failure. I don't know if you agree. Of course, less money, monetary problems, organizational problems, technological problems, and so on. Maybe things are different now. It was the mid-90s, late 90s, so of course the world was different. So now we have more robust open access journals. On the other hand, apart from being maybe a failure from that viewpoint, it also highlights one of these facets, the different faces of open science that I was introducing before. So how do we make sense of JHAP in the end? It's still open for me because I don't. Again, this is a very preliminary work, so I'll be happy to know about your own ideas about it. I wanted to close this by mentioning two ideas that I have. So the first one is the concept of recursive public, elaborated by the American anthropologist Chris Kelty. He studied hackers, and he conceptualized a recursive public, as a community that recursively maintains its technologies, its media technologies, in order to sustain the community itself. For example, free software projects. So what's interesting in this case is that if we were to look at JHAP or at the group that started JHAP as a recursive public, we're not just talking about maintaining a technology, to go back to this geeky jargon, but also maintaining a political and organizational order. Which kind of order? I think it's an economy because it's based on exchange. It's a particular moral economy of sharing. Maybe we could define it like this. But sharing is not just related to articles, which were the product of JHAP, but it's in a broader sense related to sharing, articles and work, but also reviews, labor, positions, money, and maintaining this moral economy of sharing was crucial for them to basically win their political battle. yeah, so I think this is a very fun and interesting case study, and it shows very well the interplay between technological evolution and cultural evolution, and how the two things cannot be separated from each other. And just to go back to the other case studies, I think that all of them are sort of part of a counter-symbolic order, because they do challenge incumbents in various senses. But of course, the goals of the people that start this project can be very, very different. So in this case, it was the political goal of taking back power over the circulation of knowledge in the community, power over the right over the decisions to be made related to who can publish where and who can review what. Other cases, the incumbents can be corporate actors, can be the walls of scientific institutions. So I think it's a very diverse and heterogeneous world, and life sciences are very different, and particle physics is a very peculiar field. But I think that it's interesting to try to keep them together, because the two fields both say something about what openness means in contemporary science. And thanks. This is all.